Good afternoon, everybody. You who are here on place and also those who are by the stream. So you are welcome to this event, to Tiedekulma Think Corner of the University of Helsinki. This week we have had a Biocolours conference in the University of Helsinki. The theme for this Biocolours conference was a sustainable value chain for color. And we wanted to share the conclusions and the final impressions of this conference. So altogether, there were participants from 23 countries, and altogether 155 participants were in the main building of the University of Helsinki, and we were a very diverse group of people presenting sciences, designers, companies and business life, and also scientists and researchers from different fields. So very multidisciplinary group of people. We had oral presentations, poster presentations, so 3 keynote speakers, session invited speakers, 11 oral presentations, 56 and 51 poster presentations. So total 121 presentations in this conference. We also continue tomorrow with excursions where we have 10 very diverse and interesting destinations to 10 different organizations and research institutes and companies. Also, we have organized 3 exhibitions connected to this Biocolours conference. In Craft Corner, not very far from Think Corner here in Helsinki, there is a growing season exhibition going on the entire June. So by the end of June, you can go and visit. There are several, I think, was it 8 artists presenting their works with natural and bio-based dyes. Then another exhibition here in the Helsinki metropolitan area is designing with Biocolours at Värep building in Aalto University, starting tomorrow on Friday, 7th of June, and it's for 1 week, so just 15th of June. So you have to be quick to visit that exhibition. And then the third one is kind of do-it-yourself trip to Rovaniemi. Maybe some of you online live near Rovaniemi or even in Rovaniemi. So at Arcticum Center there is these Valo and Katve galleries, and there is Seasons of Colors exhibition on exhibit the entire summer till the 18th of August. So you can make your summer trip towards Rovaniemi. I want to shortly introduce the Biocolour research team who organized this Biocolours conference. So there are researchers from 8 research institutes, from which 6 are from Finland, and then we have North Carolina State University from USA and University of Campinas from Brazil. Altogether 36 researchers have been involved, and this group of researchers and people also dedicated their time to help organizing this conference and also leading the conference delegates around in the university building. Then in this Biocolour research project, we have also industrial partners and collaborators. And a little bit of the program. So we had this blue sections with just one channel, and then we were two parallel sessions every day. We had topics from agriculture, side streams, and multifunctionality of natural compounds, also biocolor authenticity, palettes, and potential insight to the chemical structures of natural colorants. We learned that there are very different type of natural colorants and how they are extracted and what are their characters in different materials. Also, we heard about the safety of natural and bio-based colorants. Today we have also one speaker here to tell about the microbial and the potential of microbial biotechnology in color production. We heard a lot about textile coloration processes and altogether sustainable solutions in textiles, in how to produce textiles and how to apply them even in processes which don't use any water, as we all know that these dyeing processes are one of those issues that really give burden to the environment. We had many designers giving interesting ideas how they apply natural and bio-based colorants in their works. And we also discussed about, is natural better? Maybe we can continue today discussing about that topic, and altogether we explored the great variety of the colors and the color spectrum and palette that can be produced with natural colorants. So I'm very happy now to introduce our first speaker, Heidi Halbfried from Austria.
Thank you very much. Well, my name is Heidi Halbfried. I'm from the Technische Universität Wien. And from my background, I'm a plant biochemist. So my interest is very much in plants and pigments from plants. And in this, in my presentation, I wanted to summarize the most important takeaway messages which I took from this conference, and also give you a brief introduction to plant pigments. So the most important thing is that biocolors are getting more and more important because there is a rising awareness of the environmental impacts of petrochemical-based products, both from the consumer side, but also from industry. So that's where natural colorants come into discussion and getting important. And they can be used for multiple applications, for applications in cosmetics, in textile and food industries. And it was also interesting that the discussion concentrated a lot of that the innovation or the pacemakers are probably not really textile dyeing, but cosmetics and food industry. This is more the industry with more money in behind, and where the consumer concerns are also more important. So probably food industry and cosmetics will make the pacemakers, and textile industry will probably follow. What I also found very important is that the Biocolor project will launch at the end of 2024 an open database. So tools for characterization, authentication, and quality analysis of natural colorants will be found there. So this will be for sure a very important source for all the different people researching in this area or interested in natural compounds, colorants. In general, natural colorants they have two advantages. They are renewable, they're coming from renewable sources, and they are biodegradable, but they are not necessarily safer or environmentally friendlier. This always needs individual testing. Another important message I got from all these different presentations is that natural colorants are more than just pigments. They're typically multifunctional, so they can have other bioactivities which can be exploited. So this opens new possibilities, but it can also be a risk because these side activities are not necessarily always beneficial. And again, this has to be tested. In total, natural colorants can come from many different sources, and it was also a matter of discussion in this conference. That they all should be in parallel use, so there is no main source. Every type of source brings important, interesting new colorants. So the main sources are plants and fungi and bacteria, also microalgae were mentioned. And I had the impression, although today I had to change this a bit, predominantly there were plant and fungi-derived colorants, although today also there were some interesting presentations about pigments coming from marine bacteria. So, but coming now more to my topic, and I see this very much from the point of view of a plant somehow. Of course, plants do not produce pigments to please humans or to make the world more colorful. This is biosynthetic work they do to produce this, and they do this for three main reasons. First of all, they do it for light harvesting. Although photosynthesis requires the absorbance of light, and this is done by pigments, by different part of pigments. So most of the spectrum actually of the white light is absorbed by these pigments, and only this portion which is reflected is received then as color. So plants are green because the pigments that harvest light do not absorb the green portion of the spectrum. Another important function why plants produce pigments is protection. For example, against UV light or against excessive light. Also protection against radicals, because pigments have these special chemical structures which allow them to eliminate radicals, and also offer very often some protection against oxidative processes. And the last but not least reason why pigments are produced by plants is that they are visual signals. So to communicate with species outside the plant kingdom, for example, to attract insects or other animals as potential pollen dispersers. In the case of flowers, this is very obvious, and this was also an important contribution. Or an aspect in the evolution of plants, and on the other hand, to attract seed dispersers. In my next slide, we need not go, of course, into chemical details here, but this just summarizes the main important plant-derived compounds, which can be also used as natural dyes. We have the chlorophylls, which provide green coloration. Then we have a number of pigments which provide yellow, orange, and red coloration, so the betalains, carotenoids, and flavonoids. And then also anthraquinones, but these are, we have a huge range of synthetic pigments actually based on anthraquinones. They are not so common in plants, but here you have, as an example, rein, which is the red color of reverb. And really dark tones, we don't have so many actually, but one example is biopolymers like tannins and phytomelanins, which provide brown and black coloration. I found it also interesting that a huge portion, or many presentations concerning natural dyes were plant-derived or plant-associated, but not really pigments in plants, and that was indigo. We had a lot of presentations on indigo, which is an indole type of pigment. But this is not produced by the plant as a pigment. It's accumulated as a colorless precursor and actually produced by the plant to protect against bio-invaders. And it's only afterwards when we process this, and if it's then oxidized, that it gives this great blue pigment, which has been used by humans for quite a long time. And the other example is cochineal, which is just plant-associated because it's produced actually by insects, but growing on host plants, cacti, and they produce also this red coloration as a protection against predation by other insects. This I would also to briefly mention that white coloration is in plants not produced by pigments. It's actually in the absence of light-absorbing compounds. Then the air, which is included in the petals, disperses the light, and this is absorbed as white color. And you can easily demonstrate this if you put a flower or a petal into water, apply vacuum on this, just a few minutes, then all the air is removed from the water, but also from the petal. And if you release the vacuum, then the water will come into, or will fill the intercellular space, and you get immediately a completely transparent flower, as you can see on the left side in this slide. Yeah, and black is typically also not really caused by a specific pigment. It's rather that you have a very, very high concentration of red or blue pigments. And this compared actually with a certain structure at the surface, which disperses the light and absorbs the light which is reflected, so that you don't have, that you absorb basically all the light. This gives a dark color impression. Yeah, an important aspect of natural colorants from plant is that you can use as sources agricultural and food wastes, which is actually quite cheap and also very sustainable. But it has the disadvantage that very often you have varying concentrations and also very low concentrations. And typically, industry requires a standardized quality, reproducible quality. And there is room for improvement or for research. You can, for example, focus on innovative and sustainable extraction techniques, or another possibility, and we will hear more about this a bit later, is to produce these pigments by precision fermentation production in industrial hosts. One of the drawbacks you can have if you would like to produce dyes from plants, from natural pigment of plants, that not always the qualities compared to synthetic colorants, what we or what industry would expect. Often color fastness and color strength is a challenge, and one of the possibilities to overcome this drawback, and we had a lot of presentations also in this direction, is that these natural pigments are modified somehow in a way that they have a better dyeing performance, a better color impression, novel hues, or also you can, for example, prove solubility, which can reduce possible risks of these colorants, or also an easier application. Yeah, and the last message I got from this conference was that sustainable processes do not just address colorants. The whole process chain is affected. This affects not only pigments, but also auxiliaries and the dyeing process. And in general, I would say that the sessions were quite balanced in terms of focusing on colorants on the one side, but also presented a lot of new and innovative processes. Yeah, and with this, I'm at the end of my presentation. Thank you very much for the attention.
Thank you. Thank you, Heidi, for your very good points. Okay, let's go to the next speaker. We have Thomas Ostenfeld from Denmark. Please.
It's been a great pleasure to join this conference for this week. So as just announced, I'm Thomas Ostenfeld Larsen. I'm at the Technical University of Denmark, where I work with microorganisms and biotechnology. So I didn't bring any slides today, but I'm going to allude a bit to the possibilities we have with that. So some of the compounds that are produced are similar to the ones we heard from plants. They have various colors. And in my work, I've been working in particular with fungi. So you know, we have the macrofungi, we have mushrooms. We can go into nature and collect and extract, and we can use that for dyes, for textiles. We heard quite a lot of this, and there's a big tradition for this in Finland. But we can also go into the nature and find the microfungi. So those are the ones that we often find if we are not treating our foods well enough in the fridge at home. So they would be growing. There are spores in the air. They would be growing on various foodstuffs. But we can also control and work with these microorganisms in the lab. We can have them in big tanks, and one of the fungi is actually yeast that we use for making beer, but we can also make yeast produce various compounds for us by genetic modification of the yeast. So for Biocolours, we have, like in my world, so working with biotechnology is very multidisciplinary, and this is a big possibility we have now, and it's already highly developed. So we can manipulate the genes if we want to have very precision fermentations and production of some of these pigments, but we can also just use the wild types, the organisms that are not modified. So you can see we use Penicillium roqueforti for production of cheese, but we can also have some similar fungi that are very colorful, and we can use them for making extracts where we can get either known pigments or we can get entirely new pigments. So one thing I alluded to in my own talk today is that the technologies for genome sequencing in the recent years has just really progressed. So any microorganism or fungus or plant we can sequence, and we can get a lot of information about the potential of these microorganisms to produce pigments, biocolors. So that's a great opportunity, and there's also a whole field of bioinformatics. So people are developing tools to interpret all the data to know what are the potential of various organisms to use. So one aspect that is very important, and this is if we move from the synthetic compounds that we know, there's a lot of consumer trends. They don't want synthetic pigments. especially in California, in US, it's driven. They want biocolors, natural colors. And one aspect we discussed at this conference is, like you already alluded to, Heidi, is natural necessarily good? Can they also be toxic pigments? So this is something we need to look into and address. So you can say I'm working in my work with pigments or dyes for textiles. That's combination of compounds. It's an extract with compounds that are colorful, but there's also other things in it. But with biotechnology, we can make very pure pigments. But then we can use them for textiles, but if we want to use them as ingredients in foods, then we need to check that they are safe. So we heard also at this conference there's work on the old synthetic dyes, azo dyes, that a lot of them are mutagenic, and if we look at similar compounds from fungi, we also learned that some of the compounds that are named anthraquinones, they are also mutagenic, those we get from nature. So we need to test and ensure that the products we are producing in the future are safe for us. So a lot of the compounds that are produced in nature, they are bioactive, as was also just mentioned by Heidi. And regarding foods, we have the term mycotoxins. So we know that some fungi are toxic, and we don't want these toxins. But with advanced, also in my field, chemical analysis, we can also now have big databases where all the known toxins are there and data, so we can compare new fungi we have to see whether they produce any toxins that we need to avoid in our products. But I think the consumer trend is there for going for biocolorants, and I think the fungi, the microfungi, they have a great potential to deliver these compounds in the future. We just have to make sure that they are safe yeah. I think maybe we can discuss this more later on. But just to sum up my field, biotechnology, there are really great potential to make biocolors for the future. And just to mention one colleague I had, Irina Borodina, she expressed these betanins that you also showed that are plant pigments, very famous, and she could put the genes from that compound into baker's yeast that we use for making beer and make 5 grams per liter of this compound, so it can be pure and used for food. And it's already, you can say, approved. It's already in nature. We eat it, so no need for regulation. So the potential is really huge. I look forward to discuss these aspects more with you guys.
Thanks, Thomas. Very interesting. Okay, let's move forward. Then Anne de la Sayette from France. No, sorry, Richard Blackburn from UK. Now it's Richard's turn. Maybe I have been too much being tuned in this conference, but okay, Richard's turn.
Thank you.
Is this yours?
No. Oh, that was put in the middle there, was that not supposed to be there.
There are wrong slides now there.
Okay, it's just one slide. My slide's next. That's my slide.
That's yours.
Okay. So, thank you. I've had a really great week. Nice to be back in Helsinki. I was very, very grateful to be hosted by Rika this time last year when we were doing lots of hair dyeing together using some of the pigments from the Cortinarius fungi. So yeah, that's we do a lot of hair dyeing work, and I'm always amazed by what you can put onto hair, what works, what doesn't work. So I'm really interested in waste as a resource, because we waste a lot of stuff in our general lives, not least food. This is a summary of the presentation that I gave earlier today, so if you're in that, I'm sorry to repeat a lot of what I said. But we waste a ridiculous amount of food, particularly in the Western world. But it's very difficult to tap into the waste sources that we throw away as a population, what's in our own houses. And often because it's really difficult to separate and to harness something from that, and that's why a lot of it goes to waste incineration to generate energy. And that's a very low value use of waste as an alternative to landfill. But we have really amazing established food production systems all over the world where we make byproducts from food through normal processing. And I'm sure you can all think of examples. And we've done a lot of work in this area because we see these as a really untapped resource for exploitation. A really good example is blackcurrants. So in the UK, we grow a huge amount of blackcurrants, more blackcurrants than anywhere else in the world. And nearly all of them are going into making Ribena, which for those of you who've not had the pleasure of tasting it, it is a blackcurrant cordial. And from this process, there are several hundred tons of blackcurrant skin waste every year. So the blackcurrants are pressed to make the Ribena. They then are dried and they shake them vigorously to release the seeds, because blackcurrant seed oil is a desirable product, particularly for cosmetics, also for food. But the skins, before we started working with them, were a waste source. And they were either ploughed into land or sometimes even incinerated to get rid of them. And I always remember the first conversation that I had with the farmers. They're all collected together by a farming conglomerate. And the farmer said to me, "Oh yes, I'll pay you to come and take them off my hands." He doesn't say that anymore. But that's a good thing, so he can now charge £900 a tonne for this waste material. So it's not only us who are benefiting from it in our work, but he's getting a secondary benefit from his crop. So, this if we talk about value chains, this has got potential value right through the chain. We developed a method to extract the blackcurrants and concentrate up some anthocyanin pigments that we've heard mentioned before, that we could use for various different applications. And we concentrated up the anthocyanins that we do want and basically got rid of all the very simple sugars, other small molecules that actually interfere with dyeing processes, we found. We got rid of those and concentrated these up. And the important thing here is we were intending to use this as a dye for different applications. And I'll show you some of the ones that we used. But even right from the very, very start, we didn't make any assumptions about what was in there, because we know that in concentrating up some of these extracts, it might have unintended consequences. If you take enough apple seeds, you'll be able to make enough cyanide if you concentrate them up enough. So you've got to be very, very careful. So we do full analysis on this blackcurrant extract. We don't just assume because you can eat blackcurrants that this powder is 100% safe. So we check that. And also you're checking for things like pesticides being concentrated up and other minerals or metals that might be in the soil. So that's a really, really important point. But what we ended up with was something that we were really happy with. I won't spend time on this, but just to remind you, anthocyanins are responsible for so many different colours that we find in nature, and Heidi kind of showed you some examples of that. But more interestingly, what did we do with them? So we developed them into hair dyes. So here we had a system where, using one extract, a blackcurrant extract, we capitalise on the fact that blackcurrants, that anthocyanins are pH sensitive, and by either dyeing hair under acidic, neutral, or alkaline conditions, you can get a range of different colours with one starting material. So we think, so that's kind of turning on its head some of the things that some people think that anthocyanins are unstable, and this pH effect is one of the things that people say is an instability, and we thought, well, let's use that as to an advantage to do really interesting things for cosmetics. But under the same application conditions, you can use other anthocyanins. So this is what cherry looks like, and aronia, which is the one up there, which is also pressed for juice, and blackcurrants. We had people, when we published our blackcurrant hair dyeing work, we had people ringing us up saying, I've got a big pile of this, whatever it is. Do you want it to try it? And the cherry is a really good example. We had a cherry grower in the UK who was saying, I've got class 3 cherries that supermarkets won't take. And you look at these cherries, and if you'd grown them on your own tree in your own garden, you would happily eat them. But they've got the odd blemish on them, they're not the right shape, supermarkets won't touch them. So that is a travesty, but whether some legislation can sort that out, I don't know. But anyway, that's a perfectly good raw material, which is basically going to landfill. So we thought, okay, let's use that. And, that's another resource material. We also dyed silk, some amazing dyes on silk. These were shown at Los Angeles Fashion Week. We've been doing some cool stuff recently with dyeing casein fibers, and rather than dyeing them in a dyeing process, dyeing them when we make the fiber. So this is, I don't know if this is going to play because I had problems with this earlier today. Let me exit out of this. Yeah, there you can see this running. So there you can see, this is a little spinning rig that we 3D printed, and you've got the casein polymer being going through a pump, and that's been extruded through a single needle filament. You can see the filament coagulating in an acid bath there. This is casein from milk waste. It's coming through a set of rollers. It's going into the dyeing bath here. So this is the dyeing bath where we're putting that into the wet state fiber, concentrating up over the rollers. You can just see it starting to turn pink. Then it's going over a set of draw rollers at a 4:1 ratio to draw the fiber, to align it, to give it strength. And that's the fiber that's being taken up there. So you've got a dye fiber system that's made from waste. The whole system is made from waste. The fibers from waste, the dyes from waste, and that whole system it uses virtually very, very minimal energy, much more product effective in terms of productivity, better wash fastness, beautiful colour, and, as I say, all from waste material. Didn't just do that. We've also done all sorts of other types of colours cosmetics, makeup, lip balms, pigments, even labelled eggs with anthocyanins. You can get some really high quality prints onto eggs with anthocyanins. Food colorants as well. So we found that there was an amazing array of things that we could do with these waste materials in terms of using them for different things. And one thing that I meant to mention as well, we'll just come back to it, we talk about resources and waste. One of the things that I think was mentioned earlier on, I think Heidi mentioned it, was cochineal. Cochineal now is incredibly expensive. And one of the main reasons for that is that the host plants, the cacti that host the cochineals, are being cleared in parts of the world where they grow them to make space for growing avocados, because of our obsession with eating avocados. And I can tell you from personal experience of dealing with the biggest avocado growers in the world that we waste a heck of a lot of avocados as well. So that's driving up the price of cochineal because the land is not available anymore to grow the cacti, to grow the cochineal insects. So the whole cosmetics industry is currently obsessed with trying to find an alternative source of a red that can work just as well as carmine. And they'll tell you because they want to provide a vegan alternative, but the actual reason is because carmine is now so expensive. So I'll just leave you with that thought. And if you love anthocyanins, you want to keep working on conferences, there's another conference you can attend in Leeds later in the year to continue this conversation. Thank you.
Thank you, Richard, for your splendid examples of how these dyes really work on different materials. Okay, and now we go to Anne de la Sayette from France, please.
Thank you, Richard. So I am Anne de la Sayette. I am the director of a research institute in France, horticulture research, and also the founder and the manager of a business company, which name is Biocolours2024, Color of Plants, in the west part of France on the Atlantic coast, not far from Bordeaux. Well, I already said that. We have 4 activities: greenhouse engineering, green cities, and agronomy innovation, and last but not least, natural dyes from plants. We started that multidisciplinary research about 30 years ago. I think we were at the very beginning, and we were a kind of pioneer of those new pigment and dyes. As an agronomist, we are specialists of plants, yes, and we went back first to botany, agronomy, and I must add history. So there are a lot of tinctorial plants, very well known. The name are Rubia tinctoria, Reseda tinctoria, Genista tinctoria, because those plants have great potential for producing dyes and pigments. So we went back to history, but of course with our modern technique. Parallel, we start on producing dyes and pigment at big scale in order to have many application development except food. So we are working on textile, cosmetic, and painting, bioplastic. In 2007, we create a spin-off, in fact. The name is Biocolours2024, who produce and market those pigments. My presentation is short because a lot of things have been said, and I have my presentation 2 hours ago, but that works. 20 years of work has allowed us to build a large plant collection. We developed cultivation with farmers in France with very interesting yields. And all those crops, I must say, enter into the crops rotation, which is an interesting thing, essential. And we developed extraction process to produce on industrial scale. We have subcontractors in France. They produce for natural, not natural dyes, but they produced natural products for cosmetic, perfume, something like that. And there are subcontractors. They are situated around Paris in what we name Cosmetic Valley in France. So we have developed 22 dyes, for soluble dyes, for textile dyeing, hair dyeing, paper dyeing. And we also have developed pigment, which are insoluble dyes, in fact, mainly for cosmetic and for painter at industrial scale. Some success stories are new pigment for Chanel lipstick. We have also a natural hair dyeing range named Biocolours, which is very famous in France, but I think they also sell elsewhere, in fact, all over the world. And also textile collection for kids. Contribution to Biocolours. We have been in the networks of Biocolours, and I take that occasion. Thank you very much, Rika, for that very, very interesting conference and very friendly. I think we are the oldest here, in fact. So our new natural dyes are very interesting, but I am very, very interested to hear about you both on the new possibilities, and I think that everything should and must exist together and must be compared and assessed, of course, and versus synthetic dyes. And another thing is that those natural dyes from plants we grew in France, but they also grew it in India and in South America, which is very important for their economic and farmers. So our participation in dyes network, we organize a big one, international symposium and exhibition on natural dyes in Rochefort in 2011 with 72 countries and 600 participants. Perhaps we will have another one within 2 or 3 years. We have a European project specific on natural colors for bioplastic. Our pigments are really very interesting for bioplastic. The only thing is that problem with bioplastic is not color, but the polymer itself, in fact. And, well, that's it. And I would be interested to participate to that panel. Thank you.
Thank you, Anne. Okay, let's move on the stage and continue discussion. And if the audience want to ask questions, you are also free to ask and join the discussion. And also from online, you can send the questions through this chat link by the link that you got into this stream. Okay, floor is yours, please.
I thought you were leaving us.
No, I just take this in case there will be some questions. Okay, should we start with the easy question? So, what was you already taught several things that were kind of the key ideas from the conference. But if you can say only one thing, so what would be your next step in your research based on this what you heard in this conference? What would you want to do next?
I think there's a lot of things that are going on in the conference that you know we're already thinking about, which was really important to hear. Not making assumptions about natural being safe and things like that. Natural not necessarily being sustainable, but I think me personally, I think really interested in the opportunities for making colorants through different new mechanisms, be it through fungi, bacteria, ways that we can potentially grow them vertically as well, because obviously, that's kind of a counter to the work that I'm doing in food waste and seeing what the other sources are of making them on an industrial scale, because I think that's obviously the most interesting thing is how do we scale it up? How do we make it cost effective? So yeah, I think that for me is interesting going forward.
What about Heidi?
Well, for me, it was quite inspiring to find out or learn about a lot of possibilities how you can improve your extraction methods. There are more and more new possibilities that you can try, and I found some very nice ideas which we will for sure try to apply to our plant material to see how we can improve our yields actually. Because I still think, biotechnology is really a great option, I agree, but the same thing with the pigments that all should coexist. I think all the different possibilities to produce and all to exploit the different sources, they should also coexist. And there is room for improvement for all the techniques currently, I think.
Good. And Anne?
Oh, many things to say, but optimizing, of course, the process. I'm still sure that plants are also very, very interesting. So I think there are a lot of agronomy to be developed with those crops who are very interesting for some farmers all over the world. And at the end of the chain, I think that there is a confusion for consumers, for the end consumers, and we must be very pedagogic. Pedagogic is okay.
Pedagogy, yeah.
And explain pretty well to the consumer what are biocolors. And on my opinion, perhaps it is a main issue, in fact.
Yeah. What about Thomas?
So I told you that these fungi, they grow on our foods, but in nature they actually very important for the life cycle of degrading plants that are dying. So one ideal case for me would be that some of the waste product, when Richard has extracted the anthocyanins, there's still things left, which is starch of all kinds, and these fungi, they have all the enzymes to degrade that and grow, and if we can even engineer them to make another pigment for us, that would be the ideal sustainable chain where we use all the resources. So that's kind of the dream, I would say. If we can, and research is going on at VTT here in Finland. Trichoderma is a main host, and there's a lot of experience in using that for degradation of, you have lots of wood and lignins, and there are many possibilities. So yeah, that's the dream, to combine things and get both products and also use the waste we have. There's so many waste streams.
Yeah. So basically there could be, we could dream of this zero waste process that we could use everything we have, even the leftovers, then after the extraction of anthocyanins, then what is left we could feed like these microbes with this, and we could get new pigments and then use everything, and nothing goes into waste.
And just as an interesting example, we did some work with mandarin peel, which makes pigments, and in China, all mandarins are hand-peeled. So if you've ever eaten tinned mandarins, I used to eat them at my grandparents' house as a child, they're all hand-peeled. And all of the mandarin peel in China is incinerated because it won't biodegrade very quickly because it's too acidic. So we extracted out pigments, polysaccharides, small molecules, interesting flavonoids. And then the mush that was left over after all that was then biodegradable. So not only do you extract a value, but you make a non-degradable waste biodegradable.
Yes, very good. Anne, when we were in this seminar, you were one of the last speakers, and you brought this word, chemophobia, and I catched it, and also I was in another session, and Minna, I think it was Minna Autio that was talking about the consumers' aspects and how consumers think that like natural dyes are like okay, they don't so much think that they are chemicals, but then synthetic dyes are chemicals, and somehow this chemical is like a red carpet for consumers, or something that like we get scared of chemicals. So what do you think are natural dyes chemicals, and how should we cope with them?
Of course, we know that natural doesn't mean no toxicity. And that must be assessed, of course. We must be very serious. I think we are all, on that stage, serious people. I know that. But other producer must be like that also. And that's why there are some confusions for industrial and for consumer. We have to be very, very serious on a scientific point of view.
Yes, but I think also that as was it some of you said that also to increase the knowledge and spread the knowledge like for natural colorants, how they behave like in washing cycles and things like that people learn to like treat the textiles in a right way. We talked a little bit of the sustainability and also like this circular economy and zero waste processes. So what do you think that what kind of natural dyes would be sustainable?
Yeah, it's a really good question, and I kind of made a comment in a presentation this morning about doing life cycle analyses and why that's really important, because I think there's a big assumption that if you can grow it, it's sustainable, and as I'm sure most of the people here know, that's obviously not true, and I think it's reflected in fibers, you know, that all of the LCA, all of the metrics will tell you that the most unsustainable fiber we use is cotton. It's a natural fiber. It's the most unsustainable fiber that we produce. And yet everybody has an obsession with using cotton. Even organic cotton is not great. You know, the way we're currently growing it it does not compare with some of the other fibers that we've got that are much more sustainable than it. So if we assume that anything we can grow in the ground is sustainable, we're making a big mistake, you know, and there's dyes that we've been growing for centuries, like madder, for example, and from what I've seen, are absolutely not sustainable if we're growing them on land in fields that could otherwise be used to grow food. That's not going to be the case for all dyes that we can grow as plants. There will be some really positive cases where it can contribute positively to the environment, maybe to habitats for insects and things like that. But we will not know that until we do that study and actually be open to the possibility that what we grow isn't necessarily always the right thing.
Any other ideas?
But what would you prefer fiber then be? What would your preferred sustainable fiber then be? If you say cellulose is the least.
Well, cotton is
yeah.
the least.
Okay, yeah.
So
sure.
I always say that lyocell, in my opinion, is the most sustainable fiber because of the way that it's made. And actually, there are some fibers now, emerging fibers that are made from waste, that are even more sustainable than lyocell being produced on a large scale. But you know, for example, you know, polyester. If you can do recycling of polyester, is an incredibly sustainable fibre. We've already got enough polyester in the world to fulfill our polyester requirements until the end of time if we are able to reuse it and make it circular. It's a really, really clean fibre if you recycle it. The problem that it has is at some point in its life it's been made from petrochemicals. But if we can take what we've got as a waste material, and I'm not talking about plastic bottles because that's not sustainable either, you can start to recycle that. Polyester is not going to go away. We're going to be using polyester forever because of the properties that it provides. So we need to think about, in a modern world where people want all the stuff that they want, how do we do that in the most sustainable way? And the same thing is applicable for dyes. We're not going to be able to fulfill all of our colour requirements from nature, from bio sources. We're still going to require, in some circumstances, synthetic dyes, but that might be synthetic dyes that we make from natural starting materials. We might need to do some chemistry on things that we can harvest. So saying that, we should not, it comes back to the chemophobia thing, we should not paint synthetic chemicals as necessarily bad, because we can do synthesis in a clean way using green chemistry principles and make really cool stuff with really cool chemistry. And I think that's a really important message from my perspective that we need to communicate.
But do you think that these natural dyes in polyester are a good thing?
Well, you can dye polyester with some anthraquinones really nicely, but is that the best use of those dyes? I think a lot of the problems at the moment with polyester is people talking about microplastics in the ocean, for example, and shedding of microfibers. What does that do to the environment? If you actually look in the ocean, the main fiber that you see is cotton that isn't biodegrading in the oceans. And it's probably because it's been modified from its natural form through lots of different mercerization, bleaching processes, being cross-linked through easy care finishing, applied with reactive dyes that stop it degrading. And so it sticks around in the environment for a really, really long time. So we're kind of focusing on the plastics problem and missing the bigger issue that all fibers are a problem. So what we need to look at is not to separate natural from synthetic. And I hate the term natural fiber, because which fiber that we use is actually natural? Because by the time it's been processed through all the chemical processes that we apply to it, it doesn't really resemble what we find in nature. And so nature doesn't recognize it as much as it would if it was still on the plant. So I think calling things natural fibers is actually a bit misleading anyway. But I think trying to separate them as two different things and having natural on this side as good and synthetic on this side as bad is a really, really dangerous thing, because I don't think that that's true. I think that there's some really, really good synthetic things, colours, fibers that we can make that can have really, really positive circular life cycles that beat natural things hands down.
Good. Anne, you have some...
Richard, I think I am going to close my enterprise and my business. I'm sorry, but my English is not very good, and I should have a better discussion in French. And I invite you to visit us, because I don't agree regarding plant cultivation of tinctorial plants. I don't agree with you. I don't know why you say it is not sustainable. For example, for wild Reseda luteola cultivation, the farmers are really very interesting to cultivate that plant. It is intercropping. They do maize and then wheat and then Reseda or madder or coreopsis. It enters into crop rotation with a good price, low environmental impact. So we have 20 years figures and yields. yes, it is interesting. It is still interesting to grow natural dyes plants. And in some other part of the world, it is very important in the economy. So, and I don't think that, I think they must coexist, yes, but for what and for which application, and what will be the message to the consumer? Yes, and there are a big palette, as I explained in my last talk 2 hours ago. I invite you to visit us.
No, I think I wasn't saying that all methods of cultivation are bad. I was saying that they might not necessarily be positive, and some will be positive, but some will also be negative. And I think the way that we solve the problem is through a combination of growing the right plants that work well as plants that are cultivated, creating some products through microbial fermentation, creating some through fungi or other methods, and creating some by doing synthesis. And I think that the way that we solve the problems is having a spectrum of different opportunities and different alternatives for the ones that work best in each of those scenarios. So I actually agree with you that some dye plants will work really, really well, but not all of them.
Not all, but if you select them properly, they will work.
Okay, Thomas, what do you want?
I would like to allude a bit to what you have said. So this term chemophobia is like consumer concern that all synthetic is not good. We need to go 100% into biocolors. And I agree with you, Richard. We should always choose the best solution. So it could be that we have a plant or a fungus making core skeleton of our molecules, and if it's most beneficial to use organic synthesis or enzyme catalyzed synthesis to finalize the biocolor, of course we should do that. So I agree very much. Combination of different methodologies should altogether give the best sustainable solution. I agree very much. It could also be that you hydrolyze some starch, and it's still the best to have smaller pieces for combining using microorganisms. So I agree with what you said.
And maybe we also have so much varieties in all materials, base materials, where we want to put these colorants, and there is therefore also like glass or very ceramics that need a very high temperature for production. So then, for example, these organic compounds usually don't stand very high temperatures, and different type of colorants are needed. Okay, then one topic what we talked about in the conference was also this multifunctionality. Anne, you are a businesswoman, and with these natural colorants.
Perhaps not. I don't know.
So you have the color, but is the color the only quality that you rely on your product, or do you also count on other multifunctional properties that natural colorants very often have?
Yes, of course, we have done a study with Institut Pasteur for the activities of our dyes and pigments, mostly for cosmetic firms, and with cosmetic firms who sometimes communicate on those activities and not on the color itself.
So like anti-inflammatory or antimicrobial or other properties of the compound?
Other properties, yes.
What about other? Do you see that there is need to look for such compounds that are more in this multifunctional sector, or to focus on on just pure color?
I think if you can, particularly for applications, cosmetics is a good example. If you can simplify formulations to use fewer ingredients, that's a good thing. So if you can get multifunctionality through one ingredient and you don't have to have an INCI list that's incredibly long, that's a good thing. I think, proliferation of ingredients in cosmetic products makes it unsustainable because you end up adding more and more ingredients to stabilize and antioxidants and things like that. So if you can get many functions from one ingredient, that's got to be a positive thing from a sustainability perspective.
Yeah, but in any case, we should not give the impression that the pigments can really solve all the problems, because of course they have side activities. They have some possibility to eliminate radicals. They provide some protection against oxidation. But typically, probably the effect will maybe not high enough to really achieve optimal effect. So I think the side effects are very nice. We also should always check that, but it will be only part of the game. So color will be the main function and whatever you can get in addition, but we should not try to say that you will solve all the functions or serve all the functions in the same time. So pigments will be antimicrobial enough to stabilize for something like that. So natural pigments, natural compounds are for sure very often multifunctional, but this, in German we have a term, it's eierlegende Wollmilchsau. It's a fictive animal that can serve all the functions, that you can get milk and egg and the wool from one animal. Typically, this is not the case. At least you will not have optimized yields in all the directions. Yeah.
Okay, there is one question from the chat. So what are your thoughts of life cycle calculation? Shouldn't there be a lot of life cycle analysis between natural and artificial dyes and processes? Yeah,
absolutely. They take a long time to do, and they're really boring to do, actually, collecting data. If you can find people who like doing life cycle analyses, hold on to them and don't ever let them go from your research group. But they're really, really important, because otherwise we make assumptions, and I think consumers make assumptions. The industry makes assumptions because they know that it sells products. And, the life cycle analyses, they're reliant upon data, and sometimes the data is not available as well. And that, often it makes for a poor life cycle because we don't have enough data. But we should try to do them where possible, I think, because I think only then can we start to understand where we've got sustainable improvements, where we haven't. And often, where are the hot spots? Which bit of the life cycle is the problem that we can improve? Because life cycle analyses are not there to say, well, this is the situation for this product versus this, and this will always be the case. You can look at them and say, well, this product's really bad for energy. But if we could solve the energy issue in this product, it then beats this one completely. And I think that doing it that way might not mean that you solve all of the sustainability issues for particular products, but you can certainly start to improve them because you see where you can make the biggest difference. Okay, great. But do you get easily data out of the synthetic dyes, how they are produced, and how much energy they use, and raw materials, and where raw materials come from? Well, you can if you speak to a dye manufacturer who'll be open about his synthetic process. Yeah, so it's probably actually easier to get that data for a synthetic process because you know everything that you're putting into the system, you know everything going in and out, much better than you do for, plants and things like that. It doesn't mean to say that the synthetic ones come out better. Of course, it'll be a case-by-case basis. But you should be able to get really transparent data for a synthetic process. I'm not saying that necessarily is the case.
Do you have the data? I'm interested if you have the data,
well,
or a person who to contact.
For example, we've got all of the data for how we produce that blackcurrant extract. You know, we don't have the data. We were talking about this before. So how do you, in the life cycle analysis of that blackcurrant extract, if we take it from our manufacturing process to that powder, and we compare that against acid blue 43 that's used for a similar product, how do you compare that in terms of the input raw material? Because I think if I'm helping my life cycle analysis, I assume that I'm starting with that raw material as free because it's come from a waste source. It's already fulfilled a function elsewhere, and it would otherwise go to waste. But some people might say, well, no, you've got to look at the full life cycle analysis of growing blackcurrants first before you get to that starting material. So that's a point for debate. But whichever way you do it, you can start with that. We've got all the data through for what we put into making that blackcurrant extract, and then you can compare the same thing for the full synthetic process for making acid blue 43 or HC blue number 1 or whatever it is to do that. So it is absolutely possible to do that comparison.
But maybe the outcome of the life cycle analysis would then be that it's absolutely not sustainable to grow black currants, and we should stop that. And that can also not be the solution. I agree that life cycle assessment is very important. It's also becoming more and more important. It's also a focus which we have at our institution, not in my research group, but we have research groups who are very much involved in this. And from that, what I'm getting out still, from PhD exams or master exams, whatever, that it's very, very difficult to perform this because we are lacking a lot of data. It's very difficult, particularly if you have products where you use different materials, different compounds, different stuff. It's very, very difficult to get enough data to make really a reliable life cycle assessment at the moment. Yeah. I mean, I would also agree with you that using waste, is, of course, should be economically, of course, quite convincing. On the other hand, there will be enough people who will tell you that this waste otherwise can be used for fertilizer. If it goes back to the field, then it recycles the nitrogen and all the other stuff. So in a way, you take this out from the natural life cycle. So I think at this moment, life cycle assessment cannot really fulfill all the things which we would like to have from that, actually.
Thomas, I want to ask something. You are working with these microbes and yeast. What do you think of the life cycle analysis and life cycle of these dyes produced with fungi?
The honest answer is...
Have you calculated from your processes?
I haven't calculated this,
yeah.
To be very honest. So most of the yeast products in Denmark are biopharmaceuticals. So, but that's... no, to be honest, I haven't made these calculations.
Yeah. Is the energy kind of the most kind of things that
so
you use most?
If you have to run a big tank fermenter for weeks to get the product, and so it's very energy consuming.
But that could all be renewable energy.
Sorry?
It could all potentially be renewable energy that powers that. You
Sure.
know? So, I saw an amazing Icelandic company who are making astaxanthin on a massive scale in Iceland, powered completely by geothermal energy. And it just blew my mind how energy efficient that was, but then all of the energy was coming from a natural source. So it depends where you do it. If you do your synthesis in India or China, it's all going to be powered by coal. So from a greenhouse gas potential, that's a terrible idea. But if you can produce it using renewable energy, then energy is not the biggest consideration. So yes, reducing energy that we're using is important, but it shouldn't be a barrier if you can use renewable energy to power that system.
Yeah,
Yes.
but in any case, what I know, it's all about yield, and I know an example where there was an assessment for naturally produced, I mean not genetically engineered organisms, but naturally producing bacteria naturally producing pigments, and there were related group was doing a life cycle assessment. And the problem was, of course, we can use the natural microorganisms, but the amount of pigments they produce is really low. And if you then do a life cycle assessment, then maybe the outcome will not be so positive for your natural pigments. But if you genetically engineer, if you use an established host like yeast or something like that, and transfer the whole process of pigment biosynthesis into this established host, then you can typically really increase the yield a lot, and this will also improve the outcome of the life cycle assessment. So this is something which is for sure. I mean, you cannot do it for all processes. If you would like, if you need certain certificates, you cannot use genetically modified organisms, for example, because it has to be a natural source. So for some special application, it will not be possible to do this. But if you just look at this on an economic point of view, then probably engineered organisms are better, just from this point of view.
Yeah, this is definitely something that we will work on in the future when our processes develop and we know exactly how these processes go. But now we are quite in the beginning, and there are very different options and processes. Okay, then there is a nice question. So, what do you think? What is the future palette, and how does it look like?
The future color palette?
Yes,
okay.
The future color palette, yes.
The future color palette?
We have seen in the conference, we saw a lot of colors also obtained from fungi, plants, and so on. What do you think, what is the future palette in terms of bio-based colorants? So, Thomas.
So I've been made aware at this conference, been reminded that the customers are changing. We saw the M&Ms, the very synthetic colors, and they have been changed to more pale colors. I think this is the trend I'm taking. I wasn't really aware of this, but this is the next generation. They don't mind, because they know that it's maybe more sustainable production. The color palette might change depending on the customer demand, and so that's one thing I'm taking home. But also you mentioned that red is not just red, and different compounds have different stabilities in different products. So for certain products, there will maybe always be a need to find the new one that is working better. And carmine was mentioned here today, and it's just such a powerful red color in many products. And if there's any magic biocolor that can replace that and be produced in a sustainable solution way, then so there will probably be new colors, but change in what we want and what we can accept is also going on right now.
The pigment palette will change maybe. I don't think that the color palette will change. I think we will have all the colors of the rainbows. I think we will find new sources. I think they will also improve much more, so I don't really anticipate a change in the color palette, actually. I think in the pigments, maybe, there will be for sure more naturally derived pigments. I'm pretty sure about this. But I think that natural colorants have the same possibilities, that we can more or less create the same color palette. And then color is always something very emotional, and we would not like the same color probably. So this is some personal impression. So it's very difficult to say this will change in this direction, because I think we are exploiting now the full spectrum, and we will in future also exploit the full spectrum. There will be just maybe, different sources for that, I think.
But I think it's an opportunity to engage with designers, isn't it? Because I think that designers are in a really powerful position to influence what the consumer wants. I don't believe the consumer is banging on the door of different fashion brands and saying, I insist on this fluorescent yellow colour, and if I don't have that forever, I'm going to be really upset. I think that they're massively influenced by what the designer comes up with. And I think that if we can engage with the designer and say, look, we've got this, you can have any colour that you want, but actually, we've got these 10. And these 10 here are the most sustainable colours that science has been able to come up with. And if you want to use these 10, you're really helping to push a sustainable agenda. And let's see what they come up with. Because I think that way, by engaging both the design and the science part of the system, you come together and you come up with a more sustainable solution by engaging both parts. And then it's, relying upon the designer's skill to sort of say, what can I make from that palette that is desirable to the consumer? So maybe the available palette doesn't change, but maybe the palette that we want becomes limited because we want to go in that direction of sustainability. And I don't want it to be limited in that direction. And if we can come up with other ways to make all the colours that we possibly want as sustainably as possible, fantastic. I met a guy recently working for a US company who said he'd come up with a biosynthetic method to make carminic acid. And I thought, fantastic. I said, can I have a sample? He said, I can only make 10 milligrams a batch at the moment, so you can't have any just yet. But these things are coming. So.
Yeah, but at the moment.
Yeah,
and
exactly.
There will be improvement for sure.
Absolutely, yeah.
Very good. Okay, so time is running, and I don't see any hands up. Yes, there is. Can you ask? Excuse me, there will be a mic so everybody can hear, and in the stream also.
Oh, lovely. I just have to say, on behalf of us designers, we feel you should have had a designer up there. And what Richard said at the very end was that we're actually really important in the story, because we're the ones that are taking all this amazing research and telling the story and making the communication. And I think we're really key. So you've talked about the consumer and you talked about washing the fabric, but I think actually as a designer, I feel like I'm important in this, and my colleagues as well. We were all feeling a little bit left out of the conversation because we are telling your story. We are the ones, like as you said, Richard. The ones that say actually probably neon isn't really that cool.
Yeah.
You could have this instead, and that's really important. And by good design, that's how you tell the story. So I just had to speak. I had to say something.
Yeah. Thank you.
Yeah, true. No? Yeah,
Very good.
thank you. For the designers.
And I must say that was very important also, and therefore we gave one of our young researcher prizes also for the designer, for the new ideas, how to combine and how to bring actually the qualities of natural dyes, not as a negative thing, but as a positive thing and positive character. Yeah. Yeah. Great. Okay, then there's the last thing, a short...
You got a question?
There is a question there.
There is a question. Okay, sorry.
Yes, is this open? Yeah. Some words about the crops, because you were talking about the sustainability, and if the dye crops are not sustainable or if they are. But I think that we have to also think about the holistic way how we use the land, entire land, because when we think about the food production, and we know that it's far away from the sustainability, but why it is? Because we lack biodiversity. And if we use right way these crops, we actually improve also the food production. So my opinion is that actually the food and feed production need this type of crops, because this can be, for example, improve the biodiversity there on the crop rotation. They can catch the carbon to the soil. So we have to think about the entire land use, not only the dye crops or food crops, but they should combine together to make the land use better and more sustainable. This was maybe my comment, or I can maybe ask from Anne what you think about this.
No, I agree with you, because you explained that better than me, so thank you.
Very good. Okay, any other questions? Okay, there. Gisela is there, sitting.
It's a final and feeling that I have, that also social things must be considered, especially poverty and I don't know how to say equity, but I think those things are very important in a world that is so separated, not only by chemicals, natural or synthetic, but also by a lot of people that don't have food and have very hard way to survive. So I think natural colors maybe are also an option to involve people that can produce those things and have a valuable chain in all that. So I believe we should also think about this more broad issue also when we talk about biocolors in nature. Okay. I don't know if you guys agree with me or not.
Definitely, okay. And I think translating things like extraction technique. So when you design an extraction technique, make it simple enough that you could put that extraction system very, very close to where you're producing that raw material. So you're not shipping material all around the world to be extracted somewhere else, and engage people locally to develop extraction techniques so they can develop an industry to produce that from their waste in association with food production and do it that way.
And I think also what is important related to what Gisela just said also, that natural dyes are very much engaged in small cultures and small communities and their craft practices, and it's also important that we do such actions that we support these traditional techniques also going on, not maybe in the way using the toxic systems, but doing things similarly, but with sustainable and safe ingredients. Okay, thank you everybody. Then there is one if you want to conclude one highlight from the conference quickly, and we then or this discussion for what can we take home until next 4 years. Actually, what I wanted to say also, so there will be a next Biocolors conference in 2028, and it will be held in Vienna by Heidi and her team in Vienna, Austria. So this is something we can mark already in calendars.
I would be really interested to see in Vienna how much is being done in the world of structural colour, because I don't think we've spoken about that enough, and I think that the most sustainable colours going forward might not even be pigments. They could be completely made of cellulose, for example, where we create structural, or protein, where we create structural colour. And I'd be really fascinated to see where we are in 4 years' time with the innovations in that space.
Any other comments?
The most interesting thing for me was really to see how many different sources we have for all the different colors. And I like colors a lot, I have to say. And that makes me feel very positive, because I think that there is really a colorful future, even based on natural sources.
Thomas?
So of course, I'm biased. I'm in biotechnology, but as I tried to allude to today, there's so many possibilities to increase yields and design microorganisms. Let them do the work, maybe with some chemistry as well. But there are really huge possibilities to increase the yields dramatically, and hopefully that can be combined with sustainable solutions altogether. So I'm very optimistic, coming from biotechnology, seeing young researchers developing new tools to manipulate, and even non-GMO-like, and there are many possibilities. So I think it will not solve everything, biotechnology, but it will contribute to better solutions, I'm sure. So I hope new progress will be presented in 4 years.
That would be interesting to see. What about Anne?
The conference was great, but you remarked that that talk is very uncomfortable for me. I must say that. That's all.
Okay, thank you everybody, and thank you for joining this event, and we will see in 4 years.
Hopefully before.
Yes, in Vienna.
Before.
Like the Olympics.
Yeah, and follow the Olympics in France. Okay, thank you.
Thank you.